Let's go to talk about linear regression and correlation. This is a small summary of what we have to know for this section. How to create a scatter plot, and we will use the graphing calculator, simple linear regression model, correlation coefficient, and coefficient of determination. When we have two variables, an x variable and y variable, the first thing that we have to do is to create a scatter plot. So a scatter plot is a visual way to describe the nature of the relationship between the two variables. The independent variable, independent is your x and dependent is your y, because y depends on x. So let's go to see this example, and I will show you the steps by using the graphing calculator. So the first thing that we have to do is that we have to go to Stat, Edit, and then we have to enter the x variable and the y variable. L1 is your x, L2 will be your y. So we have to enter 35 and click enter, 50, 75, 95, 120, 130, 145, 155, 160, 175, 185, and 190. This is going to be your x1, your x variable, and actually it has to be under L1. Now the next step, you have to enter the y variable. So this is going to be your L2. So you have to enter the y, 5.88, 5.99, 6.74, 6.1, 7.47, 6.93, 6.42, 7.97, 7.92, 7.62, 6.89, and the last one is the 7.9. So you have to enter the data. Second step, you have to go to second y equal key, and you have to check if the plot is on or off. If it's off, click enter, and you have to highlight on. Then from the type, it has to be the first one for the scatter plot, and then you need L1 for your x and L2 for your y. So one more time, now your plot is on. You have to go second y equal key and the plot is on, and then you go to zoom and you have to go to number 9, zoom stat, click enter, and this is the scatter plot. So in this case you have a kind of a positive, y positive, because the data go up from left to right, kind of not exactly strong but fair relationship between the two variables. I say fair because the data are a little bit scattered. And this is how you create a scatter plot. Here I have the steps that I just show you, and you can go through them. and this is the scatter plot. In this case the scatter plot is made by using Excel. And then I have another example for practice. This is your X, that it continues on column 3, and this is your Y. These are the steps that we did. So in this case we have a strong positive relationship between the two variables. As you can see, the points are very close to a straight line. And these are different types of relationships. So we have a strong positive, strong negative, non-linear, this is a parabola, non-linear, and in this case, as you see, we have the data completely scattered, so we don't have any relationship. Now the next step is to figure out the correlation coefficient. The letter that we have to use is R. Now if the R is between 0.7 to 1, we have a strong relationship. If it's between 0.5 to 0.7, we have a fair relationship, and if it's below 0.5, we have a weak relationship. So the correlation coefficient helps you to measure the strength and the direction of a linear relationship. Of course, the correlation coefficient could be negative, could be positive. It takes values from -1 to 1. So if it's -1, you have a perfect negative relationship. If it's close to 0, you don't have any correlation, linear correlation. And if it's close to 1, you have a perfect positive correlation. And here I have some examples and the calculated R. As you can see here, we have a negative relationship, so the R is going to be negative. And in this case, it's going to be very close to 0. The data are completely scattered. So what I'm gonna do, I'm gonna use the previous example to calculate the correlation coefficient. So if I go back, Stat, Edit, as you can see, these are the data. So in order to get the correlation coefficient, I have to go to second and then 0, and then I have to scroll down to diagnostic on. So in this case I will get them correlation coefficient and the coefficient of determination. This is R square. So I have to click enter twice until it says done. So now I can go to Stat, I can go to Calc, and you can go to number 4 or you can go to number 8. It's the same model. Let's go to number 4, linear regression AX plus B. Click enter twice. In this case you get the slope, you get the constant for this model, and you get the R. The R is 0.773. That means we have a kind of strong positive relationship between the two variables. So here I have another example. I have the steps. One more time, as you can see, we have the diagnostic on. And this is another example that we can do it right now actually. So I'm gonna do this example by using the graphing calculator. I have to go back to Stat, Edit, and I have to click delete to all the previous data. As you can see, I eliminate the previous data because I have to enter the second example, the new example. By clicking delete, I eliminate the data from the previous example. So my X is 2.4, 1.6, 2.0, 2.6, 1.4, 1.6, 2, and 2.2. And then my Y, I will keep it as it is, even though it says $1,000, 225, 184, 220, 240, 180, 184, 184, enter, 186 and 215. So I have to go to Stat, Calc, I go to number 4, I click enter, and as you can see it's 0.913. That indicates a strong positive relationship between the two variables, and here it is. Next step is to get the linear regression equation ax plus b. A is the slope that shows the change in y per unit change in x, b is the y-intercept, and e of y, or y hat, is the expected value of y for a given value of x. So this is the same example, and then as you can see the slope is 50.729, the constant is 104.061, and y hat is 50.729x plus 104.061. Let me go back to the graphing calculator. As you can see we have exactly the same numbers. So that we follow the same steps. You go to Stat, you go to Calc, and you go to number 4 and you click enter. So you get the slope 50.729, the constant 104.061, and the r 0.913. The r square is the coefficient of determination, and we will talk about in a couple of minutes. So this is the same example by using the scatter plot in the equation, and this is a second example that I have that you can do for practice. That means you can enter the data, get a regression equation, predict the time for 130. So what you have to do is that you have to substitute x by the given value. So this is the regression equation, and I use the 4 decimals. So for 130 you substitute x by 130 and you figure out y. And then this is going to be the scatter plot with a regression line. The regression line comes from the regression equation. Now this is going to be the coefficient of determination, which is r square. It takes values between 0 and 1. And for this problem, as you can see, it's 0.833 or 0.834. So we can get it also from the graphing calculator. And this is the explanation. 83.4% of the variation in the company's sales can be explained by the variation in the advertising expenses, and the remaining 16.6% is unexplained. We take 100 minus 83.4, so you get 16.6%. The last thing that we have to know is to predict y values by using the regression equation. So this is the same example as before. As you remember, this is the equation, and again we used the graphing calculator, 50.729 for the slope, 104.061 for the constant. So this is the equation, and we want to predict for 1.5 and 1.8. One thing that I put it as a note: you can predict from x minimum to x maximum. In this case the x minimum is 1.4 and the x maximum is 2.6. So you cannot predict for a value greater than 2.6, less than 1.4. As a result, 1.5 and 1.8 are between 1.4 and 2.6, so you are able to predict. So what you do is that you go back to the equation, you substitute x by 1.5, and this is your y, 180.155, and then for 1.8 you substitute x by 1.8 and y hat will be 195.373, and I have here the explanation.